Testing, testing. Hello, everybody. We're going to get settled in here and get our wonderful, exciting IGDA Game Dev meeting going. Is this good volume? Cool. Woohoo! Trenton. Podium? Ah. Perfect. Yes, this is, yes. Well, hey, would you look at that? All right. Hey, everybody. So for today, what you'll be signing up for is our introduction, which we're running through right now. We'll go through some community plugs and other announcements. We've got 2 exciting ones lined up. And then we'll be getting into our wonderful, exciting presentation with...
Hello, I am Eric Onerheim, and I made Excalibur.js, and we're going to talk about that.
Woohoo. And then we'll mingle for a little while afterwards, and then we'll decide on a place to eat. Probably, it sounds like, either Pizza Luce or Applebee's. We'll do a vote at the end. OK, we've got 1 for pizza. Cool, cool, cool. Locking that in. So welcome, everybody. IGDA meetings are open to everyone. We aim to be a safe and inclusive community for people who want to make games or who are interested or peripheral to the whole craft of making games. It's a very interdisciplinary field, so we welcome pretty much everybody. You can participate by asking questions here at our in-person venue or online on the Discord or on our YouTube live stream at YouTube, let's see here, just in our YouTube chat. If you go to IGDA TC, that's our YouTube channel, and we'll be live streaming this as well, where you can also find the recording of this afterwards if you ever want to revisit it. But we encourage you to chime in, ask questions to our presenter, make it an open discussion. Wahoo. IGDA Twin Cities is all volunteer. Can you guys believe that? This is our board. All of us are volunteering and doing it in our free time. I'm like drifting. I'm drifting to my right. OK. I'm just going to stare at the camera. If you're interested in helping out with our events, or if you have ideas for special interest groups of your own, things you'd like to see in the area, or things that other people are talking about that you think you could do a good job with, please reach out to us. Email us at igdatwincities@gmail.com, or talk to one of us lovely board members whose portraits you can see up on the screen there, and we can chit-chat about making it happen, because not only do we have volunteer board members, we also have volunteer members who do all sorts of various wonderful things around the peripheral areas. There's a lot of intermingling between the roles of a board member and a volunteer. It's more of a do what you're able to, do what you're passionate about. So all of these wonderful people are playing an integral role in keeping our community alive and thriving. And you're always welcome to be one. Being a volunteer is just as simple as talking to one of us and saying, hey, I have an idea. I would like to do this. I would like to be a volunteer. So if you're interested, talk to one of us. This is our regular event schedule. So we've got meetings every single Wednesday. Our first Wednesday of the month regularly is Devs Play Games. It's a board game social that is here, same time as this event. The second Wednesday, which you've made it to, welcome, congratulations, is our game dev meeting, where we have presentations and socializing. Our third Wednesday is the Twin Cities Playtest, which is at Noble Robot, closer to downtown Minneapolis, same time though. And then our fourth Wednesday is MNVR and HCI, which is a VR, AR interactive media special interest group, which is at RAM5. Same time frame? Yes. Cool, cool. So super easy to remember. And we also have 2 special interest group meetings that happen every month as well. Our third Saturday of the month is the Women in Games Gathering, which is at Noble Robot, same location as Twin Cities Playtest. And then our fourth Saturday is the People of Color Get Together, which is also at Noble Robot. So a lot of regular locations. We also have a Games and Projects channel. If you have something you're working on, something you'd like the community to know about, we can set up a channel for you. Just follow the instructions in the Request a Channel channel, or talk to one of us. And there are ways you can link existing Discord channels to it to send updates. We also have merch. Check it out. If you'd like to support this wonderful community, give us money financially or just represent us, check us out. We've got merch at merch.iggatc.org. And now we're jumping into, I keep drifting this way, the news, plugs, and announcements. Starting off, Peter Yang, one of our wonderful volunteers, would like to share the Gamma Accelerator Scholarship. The Gamma Horizons Fellowship is its goal is to promote underrepresented voices in the tabletop industry. Anybody who is selected as a fellowship participant receives a 1-year complimentary membership in Gamma, valued at $300, as well as a $1,000 grant for business or operational expenses, as well as travel stipends and lodging for both the Gamma Expo and Origins, which are both big tabletop events that happen throughout the Midwest. It is generally just like a promotional, like accelerator sort of program to help support people who have tabletop things that they would like to publish, businesses as well. Just generally like an accelerator. I don't know very much about it, but talk to Peter Yang if you'd like more information, or follow any of these wonderful links for more details. And now, I'm not going to talk about this thing because we've got people who run it who are going to talk about this thing.
Hi, we are here to talk about what is Nice Moves Minnesota. I am Natalia Poteryakin. I am the president. Yes, they send us out for these kinds of things. This is
I'm Kaneli. I am I'm the secretary.
And the social media chair. Thank you, Kaneli. Okay, what the heck is Nice Moves? Next slide. We cultivate an inspiring and diverse animation, VFX, and motion graphics community here in Minnesota and surrounding regions, because obviously, you know, we got to welcome the UW Stout kids and a couple Dakota people. We provide mentorship, free monthly events, a yearly salary survey, an active Discord with job postings and feedback. So if you are involved in any of these spaces, we would really love to see you at an event or in our Discord. You can slide on in. Next slide. This is a screenshot of the salary survey, which we put on our website every year, and we gather data from as many people as we can about how much they earn, and it's something that people always say is a really valuable negotiation tool, because as you know, as an artist, we can get screwed over pretty easily, and this is a way for you to actually know what you're worth when you're talking to your boss and know what people can charge in this region. So if you also happen to work in any of the industries I mentioned, it would be really awesome if you ended up filling this out this year. All right, next slide. This is our upcoming event for July, on July 18th, which is next Thursday. We have creative director Emery Allen, who's been like a longtime veteran and legend and really cool independent filmmaker. And he's gonna talk about his career in embracing human imperfection called Artisanal In-Betweens Misspelled on Purpose. We would love to see you there. It's gonna be a really cool talk. And all you have to do is RSVP on Eventbrite. You can find the link to that through any of our social media. It's normally at We Are Nice Moves. Question, Sam?
Do you guys have regular events that you all can do that we could check out? Things like that?
Yeah, I mean, we have a monthly meetup every month. It alternates between being more of like a social mingle event at a brewery or some other location and being more of a speaker event like this. We also provide free pizza and drinks at the speaker events, so maybe that entices some of you. Any other questions? No? Okay. That is our last slide. Okay, thank you.
If you want any more information, you can talk to us. You can also ask about our Discord. We have a Discord. We have social media. We Are Nice Moves anywhere. Yeah, ask us questions. We love to chatter.
We also have a set of links that we'll be posting into the Discord and the Game Dev Meetup channel with information for both Gamma, the Horizons Fellowship, and Nice Moves, so you can follow up on either of those things if interested. Anybody else got anything? This is sort of an open space for people to plug things. It's all yours.
All right, well, first of all, this is what the merch looks like when you're wearing it. Second, 2DCon is next month. That is a games and other sort of related things convention that is hosted right here in the Twin Cities. If you look up 2DCon on Google, you'll find signups for it, and would be lovely if you show up.
We'll give it another couple seconds if anybody else has any other things they would like to plug. Oh boy, heck yeah.
All right, steampowered.com. A lot of you probably don't know, a lot of new faces. I used to run this meeting like 10 years ago, only for 3 years, so. But can you look up Astral Gunners? So back when I had the meeting, these guys, they just released. There you go, June 21st. So I thought I'd throw out a thing for them. I don't see them here, but whoever runs this meeting should try to contact them and see if they'd come back and talk about it. Because it's like 20 years in the making. It's pretty fun though, back when we used to do play events back then, we'd have this a bunch. I don't know if they still show up to game tests or anything like that, they might, but it's been a while since I've actually seen them around. Anyway.
All right, thank you. Woohoo. All right. Oh. Going once, going twice, going thrice.
Okay, so I host Nice Games Club. A lot of you know that. It's a weekly indie dev podcast. Listen to it wherever you get your podcasts. But this week, we interviewed famous, legendary designer Ron Gilbert about puzzle and story. And I thought I would, crow about it for a moment. Anyway, you can find it. NiceGames.club is the website, or Nice Games Club, wherever you get them. And that's kind of it. Okay, great. From Noble Robot on East Hennepin Avenue in Relational, Minneapolis.
Yeah, we can just skip the whole meeting, just do that instead. And while we've been doing all these wonderful, amazing plugs, it's reminded me of a plug that I personally have to share. I am one of the co-hosts of a monthly asset jam called Jamma Jam. We'll be coming up on our monthly our 1 year anniversary next month. Really fumbled that one. So we'll be doing a very big special jam. It's basically 48 hours the first weekend of every month, and you're invited to create an asset based on the prompt or theme that we give. And then we do like a whole community voting for awards. It's a great way to flex your skills, try out some new things you haven't already, just generally create something that you've been wanting to make. So we would love to see people there. I'll post a link to our Discord in the Game Dev Meetup channel if people are interested in joining. Okay. Any other plugs? Anything? Going once? Going twice? Sold. Now we'll get into our wonderful, amazing, exciting main presentation. Thank you very much, Eric.
Thank you very much. I will also second the Nice Games Club podcast. I am an avid listener, and I just listened to the episode with Ron Gilbert. Very good. You should listen to it. Yes. Excellent. So my name is Eric Onerheim. I'm local. I live like 10 minutes from here, so that's awesome. I built Excalibur.js, which is an open source TypeScript game engine for the web, which is fantastic, I think. So let's talk about that. So Excalibur, made in TypeScript. Excalibur is a game engine. One of the classic developer traps of any developer is building a game engine. If you build a game engine, it will never let you go. You will be doing it until you die. It is also kind of like category theory, programming in Haskell, functional programming, compilers. If you get into compilers, you'll never stop. It's one of those classic developer traps. This is a great quote. Give a man a game and he'll have fun for a day, but teach a man to make a game and he'll never have fun again. I've actively tried to not have this happen, so I try to build games as much as possible while building a game engine, because one of the classic traps is you just do that and you never build games and you're kind of out of touch. So I try to build as many games as possible. I build at least one a year, and that's Ludum Dare, but sometimes more. I have a lot of fellow maintainers, contributors, and partners in crime. They're awesome. They all help a ton. The community has like tripled in the last year, which is absolutely bonkers. And everyone is super friendly. Jay is my project manager and talks me out of bad ideas. Kamran is my idea person who gives me lots of ideas. Matt is super sharp. Like he's the the dog food, building stuff with stuff I made and finding the wild bugs in it. Chad is also really great at bouncing ideas off of. Really helped ideate some of the new features, especially around accessibility. Chris is doing some cool stuff out in Australia. Drew is a friend of mine who's doing Excalibur content on his YouTube channel. And Alan is also a person that talks me out of bad ideas. So go check out all their stuff. I really recommend all of these links. You should go check them out later. Yeah, really cool stuff. All right, so me, I'm a full stack dev by day. So what does that mean? I build normal business software. Boo. It's pretty fun, actually. I do front-end stuff. I do stuff in TypeScript. So this whole TypeScript game engine stuff keeps me pretty sharp. I do a lot of game dev for fun. I have a couple games that I'm trying to get out into places. So we'll see how that goes. I have a blog at ericonerheim.com where I blog about random problems that I have. And some of them are like physics engine stuff, and some of them are graphics stuff, and some of them is how you center text, which is a wildly difficult problem in the Canvas API. And then ExcaliburJS.com is where you can find all of the Excalibur goodies and links to everything I have today. But I'm a brand new dad. She kept me up all last night, so I might be a little weirder than normal. So that is going to be fun. I have a lovely cat. I wish I had a picture of her on here, but she's Siberian, so she's got like tons of hair, and it's everywhere all the time. In my food, in my bed. It's amazing how much cat hair is everywhere. And like, you just vacuum, and there's like cat tumbleweeds like an hour later, and you're like, I need a robot. That's on my list, actually. That's on my birthday list, is robot vacuum. Distance runner. I'm getting over a lot of travel, so I haven't been running as much lately, but I do theoretically have a marathon this October. I should probably know when it is. That's probably important. And then I do a bunch of math and physics nerds. I'm like this close to actually having a degree in math. I failed one class, so I don't actually have a degree in math, but I'm literally one class from a degree in math, so there we go. That's my claim to fame. All right, so what are we going to talk about? I'm going to talk a little bit about the history of Excalibur, some of the motivation, a lot of the philosophy, and like why we do the things we do, and some of the motivation. And I'm going to try not to beat around the bush too much, and just show you how to build games in Excalibur right away, and not give you like the whole hoity-toity detail. And then we'll kind of dig into like how it works a little bit, and like if you're like, Excalibur's cool, but I just want to take some of these concepts and build them in my own thing, or a lot of these concepts translate to other languages as well. You don't need to be using TypeScript or JavaScript or web technologies at all. A lot of this translates directly to any language that you're using to build games, or your own game engine if you are also doing that. And Godspeed, because I've been doing it for a long time, over 10 years. We'll talk about like the API, some of the design decisions, some of the, I've built games on there twice. You can tell I'm tired. And then some of the future of Excalibur, where we're going. We're, knock on wood, hopefully going to having a V1 release here this year, 2024. That's when it's going to happen. I have one more release, and then we're going to start doing release candidates. Dun, dun, dun. And then we'll have Q&A. Okay, so why TypeScript / JavaScript? Well, JavaScript is kind of fulfilling the promise that Java had of running everywhere. You can run JavaScript on literally anything, whether you should or not, like you can. So that's kind of why TypeScript is also appealing to me because I like types. But JavaScript is really ubiquitous in our platforms now. And now that we have like things like WebGPU, WebGL, the Web Audio API, HTML Gamepad API, you can plug in a gamepad. There's the HID API, Human Interface Device API, so you can plug in just random, you can just slam in USB devices into your computer, and then they'll work on the web. It's absolutely wild. So like the web can really do a lot of stuff. And it's only gotten more and more wild over time. So this slide is from Brendan Eich's famous talk, Always Bet on JS, from, I think it's Passenger? Always Bet on Black is the quote, I think, from Wesley Snipes. It's a classic film. You should watch it. So our releases have started since 2013. I've been doing this since 2013. If you want some comedy, you should go back and look at those early commits, because they are wild. How I'm like, whoa, this is how I thought you write programs. You know, if you ever look at your old code and you're like, you know, who wrote this? Oh, it was me. You know, I am the one to blame. I've written so much of this code that I come across sections of it I don't remember writing. And I'm like, why did I do this? Who did this? Who thought this was a good idea? It was me. So I think that is a positive. Like, I think if you look at your old code and you're like, this is good. Maybe you're not, maybe you shouldn't, no. But anyway, so our releases are, you know, obviously very sporadic. And you can see they tend to be longer and longer over time. But it has this kind of neat effect of being like kind of a weird form of generative art. Happy, happy little releases. We have GitHub stars, which are like internet points that you can cash in for nothing. But we have more than 1,500 of them, which is great, and it grows. Line go up, yay! Line go up. I don't. In all seriousness, GitHub stars are kind of like a weird metric of like, okay, we trust you, but not really, because it doesn't have any value and they're free. All right. So that was a little bit of history, maybe ancient history. So some of the philosophy is game engines are kind of obtuse, and I'm gonna try not to wander from the camera. But game engines are kind of obtuse generally, and game programming is hard. One thing that we really want is to be friendly everywhere. Like, that applies to the API, the programming, but also applies to the people. So we really, 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 really emphasize being incredibly friendly to people on our Discord and on our GitHub discussions and our issues. Like, that's a core tenet, is how do we make the most inviting community, the most friendly community that we can, and the friendly game engine. That's our tagline. We're the friendly game engine. How do we be friendly everywhere? So a lot of what drives us is, this is number one on purpose. I think it needs to be friendly. Low effort to use. This should, you know, sometimes you think this would be a given, but it's not. It should be low effort. You should be able to do the thing you want to do without much effort. And sometimes that's not true, but when we find things that aren't like that, we're like, okay, how do we fix that? How do we make it low effort to use? Is it writing better documentation? Is it designing the API in a different way? Is it X, Y, Z? But low effort stuff is good, I think. Maybe you all agree. No, I want it to be hard and complicated. It should be intuitive. It should be like, oh, you should just fall into the right thing. We call this the pit of success. It should do the right thing by default, and the thing you think it should do is the thing it does. Intuitive, right? And sometimes that doesn't happen, but that's our goal. So a lot of game engines are really emphasize performance. You know, we recognize that performance is really important in a game, but you can really go to the purest madness on that scale. It's like, this is the most performant thing ever, impossible to use. So usability is kind of where we balance. It's like performance balanced with usability. So how do we get something that is good or great, but not perfect, but is also usable? So don't let the perfect be the enemy of the good, kind of thing. I'm looking directly at some ECS libraries right now. Okay, so we got some features. We got a ton of documentation. So I put this first for a reason. Documentation is the single most important thing you can do for a project. Your code can be terrible. Your project can be not great. There could be problems, but if no one knows how to use your thing, they're not gonna use it. Your code could be perfect, But if your documentation sucks, Microsoft, you can't use it. Like, it's unusable. Like, it's really hard to use, and they've improved a lot. Okay, I know that was maybe an unfair jab, but or not. I don't know if you've ever been spelunking in Microsoft documentation and ever found what you were looking for. But documentation is the single most important thing you can do. So we pride ourselves on that. I update the docs every week. People bring up questions that I had not thought of before that are completely appropriate for the documentation. I'm like, I did not think of that because psychically I know all the things about Excalibur because I've been doing it for too long. The API is kind of theater-based. This is common. We have scenes and actors. You can think of scenes like a scene, like it's the current thing being drawn. It's kind of how you orchestrate, like, this screen in your game has a scene. Actors you can think of as like Unity game objects, or I forget what they're called in Godot, but you can think of them as kind of a, batteries included thingy that draws to the screen and moves around. It's very much object-oriented, TypeScript first. You can use it without TypeScript. I know some people are allergic to TypeScript, and that's okay. You can use whatever makes you happy. Like, that's the other thing. Just use whatever makes you happy. If you're happy and productive, use that thing. You don't have to use Excalibur. You won't hurt my feelings. And it's very similar to Unity or Godot. So if you're like, oh, I like those kinds of things, you'll like this. Sprites, sheets, animations. We have our own built-in collision system with arcade physics, kind of like, like you're building a platformer, or you got something top-down, where you don't need like super robust physical interactions. And then we have realistic physics that are like, think Flappy Bird, or Angry Birds, or physics puzzles. You gotta launch a catapult, and you launch a boulder, and you knock some stuff down. That's realistic physics. And we wrote it all ourselves, which is absolutely bonkers, and the most insane code to debug. We have we have 2D and isometric tile maps. You know what they say about isometric? It's best-ometric. So if you make an isometric game, people will play it because inherently people love isometric. At least I do. We have custom shader support, which is both for individual actors and for the entire screen, so post-processing. Everything is batched by default. You don't even have to think about it. It just happens. Like, you have to actually try to not have a batched draw call. So everything is batched by default, so it's really, really fast to draw things. There's an entity component system. Notice it's last. And some people really like entity component systems. I really like them for like code organization. So, and in JavaScript, doing entity component systems for like performance reasons, it's kind of not going to get you far. It might get you pretty far, but then you kind of sacrifice other things. But yeah, so we have an entity component system. In fact, the entire internals of Excalibur are ECS, but we present an API where you could just honestly ignore the fact that there's an ECS there, and you would feel just fine. You wouldn't be sad. You don't need to know that an ECS exists. So we got a lot of plugins. So, once you have a game engine, you'd like to get your assets in there. So Tiled is a popular one. So we have tiled support, so you can just, slap any tile map format, compression format. We support every little bit that you can flip in tiled, except for hexagonal tile maps and staggered tile maps. Sorry, we're working on that one. But we can load up a game. This is coming from that tile map. And you define where your NPCs are, where your baddies are, and it just works. We have LDTK support, which is pretty fantastic level design toolkit. It really emphasizes usability. It's kind of been my favorite thing lately. This is what I've been reaching for if I'm not building anything isometric, because it just does 2D top-down tiles. I mean, I guess you could do a platformer with 2D tiles. But we also support this. We don't have as much feature support, but again, we can load this in just natively. You just load in your LDTK file, and Bob's your uncle. I don't have an Uncle Bob. We also support the brand new Spicy Sprite Fusion. It's a web-based tile editor, and we can just load that sucker right up there too. That's pretty slick. We support ASprite files, both the JSON and the binary .asprite. So you can just load up your binary, which is wonderful for like iterating. Like if you can just like work and save on your ASprite file, and then it just updates. You just do that, and you can grab your animation by the tag, and it just works. It's pretty awesome. So you grab your animation, you have an actor at a position, and you tell it what graphics to use. Bam, it's working. We have JSFXR. Whew, that's a lot of consonants. We have audio support there, so you just pass it a config file, which is a lot smaller than downloading a WAV file. A lot smaller. So you can do that, and you can play audio just off of that. It's pretty cool. We have a lot of pathfinding. We have A-Star and Dijkstra built in, with probably more on the way. I have an example of how to do least turns pathfinding. So if you like a tactics game, that's kind of a thing that you want to do, maybe just for aesthetics. Cool. We have a lot of templates. So I don't know how many of you are web programmers, but we have most of the things that are webby, including vanilla, which is not a framework. That's just as it comes. Like the browser, like new tab. That's vanilla. It's just normal JavaScript and not any of this fancy stuff. But notably, we have Vite, Parcel, Rollup Webpack, and then some of the interesting ones is if you want to deploy an Excalibur game to mobile, you might look at a Capacitor. It provides a shim between you. It's kind of like if you ever did Cordova, our phone gap, if you're old enough to remember that. But you can do just mobile apps, like Android apps. I have a new phone, but I would show you. There's Electron, so you can do desktop apps. A friend of mine has 2 JavaScript games on Steam with Electron, and no one would know. They're built in React, and no one would know. If you've looked at Athena Crisis, it's on Steam. That is built in React. Hard to believe. If you play that game and you're like Advance Wars fan, like I am, you would never know. And then there's Tari, if you're a big Rust fan, which is very similar to Electron, but the backend is Rust instead of Node. So if you like Rust, that might be your thing. Tari also touts a very small download size because they use the browser on your system. That's a double-edged sword because browsers be different. So be prepared for those bugs. Electron wraps up a browser with it, so you can count on it working the same wherever you are. Okay. We also have a browser extension for debugging Excalibur games, which is awesome. It's super great. So in here, you can like toggle on and off-screen or on-screen entities. You can search for named actors, so you can give them a name. You can also see performance, so you can see like, okay, my screen is struggling to stay at 120, but yeah, pretty cool stuff. You can toggle on and off like the name, the ID. You can show the collider bounds. You can show the graphics bounds to see like what you're dealing with. So right now, they're very light green rectangles. Those are collider bounds, and the yellow rectangles are graphics bounds. So you can kind of see how things are going, especially when you're like, oh, how do I thing, or how do I see if like, hey, I created a thing and I'm not seeing it on my screen. Having a debug tool is super helpful. Yeah, and also like knowing where your pointer is on the right there is important. We got your frame budget here. You can see like how much time your updates or your draws are taking, yada, yada, yada. Very cool. It's on the Chrome Web Store. You can go download it. It's not on Firefox yet, but that's on our list. I have a huge wish list, by the way, if you want to get into open source. I have a gigantic wish list of things that I want and will accept PRs for. Fair warning, extension development is the worst. Voice of experience, because I built that one. It sucks. Chrome, yes, question. Good question. The question was, is there an advantage to doing an extension versus in the game itself? There is an advantage. You don't have to remember to build it into the game. Now you can poke the APIs directly and get all of that output that you want, because all of the debug viz is actually cooked into the engine. Just the extension just pokes at it. In this case, but we did have a plugin where you had to compile it into your game, and that kind of was rough because you had a bug and you're like, oh, okay, well now I got to go compile the thing in and then see where my bug is. So anyway, 2 of one, half dozen of another. I don't know. Extension's kind of nice though for me. We have a lot of samples. We've been working really hard on making high fidelity samples. The latest one is Jelly Jumper, which was mostly built by Matt. I contributed like this much to it. But Matt Jennings really did a fantastic job. He went and recorded Super Mario World and like counted the frames of each part of Super Mario World so the jump feels like Mario in Super Mario World. So if you ever want like a super high fidelity platformer, definitely go take a look at that. We have pathfinding, we have UI. Turns out HTML is really good at UI. So if you want game UI, you should probably use HTML. Just food for thought. We have a tactics game, which I'm a huge tactics fan. I'm a super tactics nerd. I played a lot of Advance Wars. I played it so much that I wore out my Game Boy. And then we have a bunch of other examples here on the slides. The community has done like a ton of stuff. So Drew is doing this like Mega Man-like, which is really cool. He's making a lot of progress. Manu did this little like farm sim thing that is really cute and it has super pleasant music that I have muted. This fellow did, I think it's Matt with like 4 A's, did a Ski Free clone, but you can like compare the ghosts to everyone else that is doing it. I'm completely rubbish, as you can tell. I'm the one that is controlled by the human. I'm doing very terrible. And then at the end, I kind of give up and I just bomb the hill. This is an example of shaders. So these are all built with shaders. Like all of the graphics, you'd be like, whoa, I didn't think Excalibur had 3D. No, it's just shaders. Also, the same person who did that has been working on wave function collapse. So there's an example of that, doing some really cool stuff. If you want to read more, there's blog posts on the excaliburjs.com about wave function collapse. This one's really fun, using the Excalibur physics in a way that I had never considered before. The game is called Amazeballs. And it's kind of like those old games, like where you try to get the marble down in the right hole. I don't know, I had a lot of fun with that one. This person is making a legit 2D card game in Excalibur, and it's so cool. I have no idea what's going on, but I love that there's a card game because I want to make this. This is a game I want to make. And their partner did all the art for it, and I'm like, this is so crazy. This one is an MMO, doing like some of their tests. They're casting spells. This one is pretty wild. This is like generating a story just live. It's kind of like it's giving you prompts, and then you click on things, and then a story happens, and it reads out what the story is happening to you. It's like a play-by-adventure, but like you click and it makes a thing happen. It's absolutely wild. I've got some multiplayer happening here. Yeah, and I think those are like all of the community stuff that I wanted to show. But it's absolutely wild what people are doing. And in the last year, it's been pretty amazing to see. Okay, so what are games that we've built? I promise I'll stop hyping on all the stuff. We did top 100 in LD31. We made a puzzle game. There's going to be a theme to that. We learned a lot of lessons. One, color blindness is a thing. Did you know 1 in 10 are colorblind? So this game is definitely not colorblind friendly. I'm very sorry. We found a memory leak in Windows Phone. That was pretty cool. That's not really useful anymore, but we found one. QA is really powerful, so we were just deploying and having the QA play on a continuous cycle. And having dedicated QA is super powerful because you as a developer, are going to psychically ignore the problems. You're not even going to try. You're just going to actually ignore the problems without even realizing. You're like, oh, that could never work, so I'm never going to click there. A QA person doesn't have that inhibition, so they're just going to click there and break your game. So definitely have a QA. Our second most popular, we did 134th in the last LD. We made a puzzle game that we showed off at, it's called Some Monsters, that we showed off at Playtest a few weeks ago. Yeah. And a fun story about that is the kids did really well and the adults did really poorly. But it's a math game that's like Sudoku. So you're supposed to sum up the rows and columns to the right number. And let's see, I have a video here of like these cute little duders. So you're like, that column on the right, or excuse me, stage left, your right, needs to add up to 0. And then that one on the top needs to add up to 6. So yeah, it's pretty fun. And my partner was playing it like all night, and she was like, I need more puzzles. You need to send me more puzzles. So I like literally the next day I was like working on puzzles. Fun fact, this was prototyped in Excel. So, you know, definitely do that. You know, use Excel. That's awesome. Excellent, excellent. I like that. Joke from the audience. That was pretty great. Okay. I have been talking at you for way too long without showing you how to build a game. This is a quote of mine from like 5 years ago. The dirty secret to building games, or software for that matter, is tricking your users into thinking it's working. Because it's all smoke and mirrors. Like, people are like, how do you do pixel perfect collision? I'm like, pixel perfect collision, they're circles. I didn't do that, that's too hard. You know, and a lot of times, like, you know, the most correct thing, you don't have to do that. You can get away with like pretty good in games and in software. So let's take a look. You know, I'm just gonna use the video because I didn't think about typing live with a microphone in one hand. So we're gonna do the video and I'm gonna narrate. So really cool. Hello. Oh my God. Okay. Well, all right, now I'm gonna do it live. I'll do the video then. I won't make you stand there and hold my microphone. I appreciate it, but I'm gonna pause the video. Much appreciated, Trent, I appreciate it. You are a gentleman and a scholar. Okay, so we have, if you're familiar with WebDev, WebDev is insanely complicated now. It used to be like Notepad HTML and Notepad.JavaScript. Now it's pretty wild stuff. So we have in the Node and NPM community, the Node is the server-side runtime for JavaScript, one of them now, one of the competing ones. And NPM is kind of the package manager, so think Cargo and Rust, or NuGet and C#, that kind of thing. But in NPM, you can create scripts. So we have our own called Create Excalibur, and that's just on the NPM registry as create-excalibur. But if you make a package like that, you can run this kind of command, which will go ahead and scaffold an Excalibur project for you in your favorite bundler. So I picked Vite there. One nice thing about this is there's a lot of boilerplate to setting up a project with a bundler nowadays. And this just kind of like, you right through that. It's kind of a nice thing. I use it daily, especially when I'm reproducing a bug. I'm like, wham, let's just like, okay, this is the name of the bug. I'm gonna go ahead and do it. So by default, you get this little lovely project with a sword, the Excalibur logo, stickers in the back, and Bob's your uncle. All of these are powered by our open source templates, so on GitHub. So it just downloads the template from GitHub and runs npm install and gets you going. So all of this stuff just powered by the open source templates. So if you're like, oh, I don't really like that, or there's a bug, or I want to add something, it's all open source. Cool. So I'm going to show you what I like to do when I lay out a Excalibur project. So I'm opening everyone's favorite editor, VS Code, and hopping right into main and promptly deleting everything because I believe in showing you the things that are happening. So we're going to stop right there. I love this. So in Excalibur, there's the type called engine. And it's what you think it is. It runs all of the things. It runs your code. But you don't need really engine around very much. So what I like to do is have a main file. It could be main.js, it could be main.ts. But the goal is to get in, configure your engine, get out, and then have the rest of your game elsewhere. Don't have all your game in one file. That's pretty rough. Trust me, I know. I have done that before. Oh, and we're going to see some Matt Jennings cameos in here. But you can specify your width and height in pixels. We have a bajillion display modes. My favorite lately is fit, screen, and fill, which means it'll preserve the aspect ratio, and then instead of having letterboxes, it'll give you dynamic resolution to the end of the screen. You're not guaranteed that area, but it's kind of nice if you want to not have that letterbox. You can still have the letterbox if you just do fit screen, and then it'll just give you like whatever the HTML background is. So if it's, you know, chartreuse, pink, black, I don't know, pick a color. The next thing, let's see, can I scrub in YouTube videos? Nope, that was a mistake. All right, the next thing I want to highlight is one of the patterns I like to do is just creating a resource dictionary in JavaScript or in TypeScript. This is kind of a cool little construct here. I have const as const, which is, you might be looking at that sideways being like, what in the world are you typing? It's actually, so the const part on the first part is JavaScript. The as const, that's TypeScript. Basically saying, okay, the first one is saying this reference will never change, so don't let anyone mess with it. The second const is saying these keys, you can count on those not changing, and TypeScript will enforce that. And you can say like, oh, I know that sword is type image source. That's just texture, but again, friendly and usable. Image source is very clear what that is. If I went up to a layperson and said, a texture, what is that? You know, is it smooth? Is it rough? I don't know. Texture is just a bad word for images, I feel like. So we use the word image. And then we go ahead and export a loader with we're iterating through all the keys in that resource. So a lot of times what we'll wind up doing is so here I have an image, but I'll have sound, I'll have more images. I might have that tiled map in there that I'm loading. I might have Sprite resources that I'm loading, and I can do that all up front. You can also load resources on demand if you need to by scene. So, you know, you don't have to load up your 400 megs of game before you can start playing the game if you have lots of levels. So generally it's easy to load things up front depending on how big your game is, but you could definitely load it by scene as well. So the game starts and you give it a loader. It will load that and then proceed into the first scene. By default, all Excalibur games have a scene built in. So if you were to go and take a look at this actor, again, this is the OOP API. So this actor at a position has width and height, and it's using some graphics that I just loaded. If I were going to go ahead and add that to my game, dun dun dun, it'll get added to a default scene. So whatever the current scene is, in this case it's going to be the default, it's going to add it. And if I run this, 0% of things will change, except now you'll notice there's no letterboxing. And there we go. One thing that I didn't call out is there's this little pixel art guy right here. We have a special shader for doing really pretty pixel art. So if you do the pixel art pragma, we'll bounce you into doing pretty pixel art rendering and doing special subpixel anti-aliasing while preserving your sharp edges so that you can rotate your pixel art and not have the weird jaggies. Yeah, it's pretty cool. It's pretty dope. It's using Inigo Keylase shader, so if you want to do that yourself, go look up Inigo Keylase. So, you know, adding things to the default scene can get pretty wild pretty fast, and you could definitely build games that way, but I generally recommend breaking your game into multiple different screens. So generally what I do is I take, you know, the scene and I extend it, and I make my own scene, and in the onInitialize, I'll do my composition of my game. So I'll add whatever's there, like maybe I'll have a tile map, I'll add it in there. I'll have my player here. But, you know, everything you'd add to the scene. You make an actor, you add it to the scene. And then we'll do this. Instead of adding it to the default scene, we'll go ahead and define the scenes in my game. And now you can dynamically add scenes, but this is a static. So you can statically define scenes or dynamically. The advantage of doing static is now you have type hints, TypeScript for the win. So you can see that there was level. Let me see if I can back that up. You can see that there's the level scene, and then there's the root scene, which is the default that always exists. So I could say, oh, I want to start on this scene now, and I would like a fancy transition. Specifically, I'd like to fade in. I'd like to fade in from black, please. And then I got ahead of myself. But you can transition between any scenes. You can also override scene transitions on the fly if you decide like, okay, well, I have a static scene transition defined, but I want this different one for my awesome Pokemon battle sequence. But here we go, fade in from black. Yay, fade in from black. So fun. It's so fun, I did it twice. Cool. Let's see, what am I gonna do next? I don't remember what I did. Oh, now I do. So sometimes you wanna like script behavior. Like you want your thing to move around across the screen. And you can totally do that in like an update loop and like update positions and velocity and stuff like that. But that's kind of a pain in the butt. So we have this Actions API, which allows you to, this was stolen directly from Cocos 2D, but we have this Action API that allows you to like move by, rotate by, scale by, move to, rotate to, and then you can do cool things like this, where now I can move my sword logo in like a diamond pattern. Very cool. So this is great for like if you have patrolling enemies, you have some sort of AI script, and this is really great for like kind of the simple things. For things that start to get a little more complicated, Excalibur also supports coroutines. Those are great for doing animation over time. Coroutines are really great for doing computation over time in general. So if you want to amortize computation over multiple frames, coroutines are your friend. Turns out, computation over multiple frames, that's also called animation. So coroutines are really great at that. We also have this repeat forever, so if you wanted to have something bounce around and spin forever, you can totally do that, which we just wrote there. Cool, awesome. Now that's exciting and all, but we would really like our sword to point in the direction that it's moving. So we also have all of this vector API stuff where you can say, hey, the current velocity of my actor, I want to grab the angle of that. And my asset was like phase shifted by pi/4, but now when the action moves around, now my sword points in the right direction. So this is pretty fun. Yeah, pretty slick. All right, I think next I'm gonna go, now I'm like, I recorded this literally at 1 a.m. last night. So now I'm gonna make another scene, but yeah. Thank you, my beautiful daughter, Maeve. I'm gonna make another scene where we're gonna talk about physics. So in this scene, we're gonna genre hop, and in this scene, it's gonna be a physics game. So we're gonna go ahead and make some blocks, and the blocks are we're gonna click and add a block. And you'll notice that I really throw around the new actor a lot, and that's how my games look a lot of the time. But other times, like if you want more specialized behavior, you'll extend an actor kind of like object-oriented style. But a lot of times you can just throw actor around and Bob's your uncle. I don't have an Uncle Bob. Again, we create the actor, we add it to the scene. Da, 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 da. I might have to speed this up because I'm just like getting amped. All right, so we have input API, so you can do input pointer, input keyboard, input gamepad. Maybe in the future I'll add HID stuff, human interface devices or other things, but we can go ahead and go to a scene that we've defined, so I'm gonna define them statically. You can also just, go to a scene that you know exists, but then you're kind of like outside of TypeScript's realm. Buyer beware. So one thing you can do is grab pointers. Whoa. You can grab pointers, and the pointers have world position, screen position, and page position. So usually your world position is like where you are in Excalibur. Screen position is where you are according to JavaScript on the screen. So huzzah! I can click and add things to the screen. Very nice. But now I want physics. So we can go back to our engine here and go light up some physics. Physics by default uses the arcade solver, which is like 99% of the time, that's kind of what you want in a 2D game, is you want an arcade solver for like physics. And it doesn't do any like realistic things like you bounce off stuff or friction or anything like that. It just keeps you from overlapping other things that are solid, is the gist of it. So if I'm going to make a physics game, I'm going to need a floor. So we're going to go ahead and make a floor here really quick with an actor. We're going to position that at the bottom of the screen, 0, 800. Actors by default are center aligned, which was a choice. So people coming from other game engines might be like waiting, like everything's from the top left. But Excalibur actors are center aligned. So in this case, I want it to be from the top left, so I did anchor 0, 0. And that'll put you at the top left. 0.5, 0.5 is the default, which is right in the middle. 1, 1 is bottom right. So there you go. Now I got a little floor for my physics. And now I'm going to go ahead and make them active. And this one is fixed. So this is like in Unity if you did dynamic and static. But I'm going to go ahead and switch my scene here. Go ahead and click. And now, hey, physics game. That was pretty fast. And you'll see that that wasn't very realistic right there. And that I demonstrated that on purpose. It didn't fall off the edge. So you can do your Castlevania like edge creep there. Now I can switch the solver to realistic, and then we can go ahead and reload that, and then play around with some fun blocks. And we support polygons, circles, composite shapes, so you can take multiple shapes and combine them together into, like, say you have a tank and you really want all of the bits of the tank to be a collider. We also have a built-in capsule too, so like if you're doing a platformer, a lot of people like capsule colliders, so you can do that as well. Yeah, the physics system, the realistic solver is very similar to Box 2D. It uses the same technique, which is called impulse, what is it, constraint-based. What is it? It's an impulse-based solver using constraints. So what that means is over time, I give little tiny nudges to the different things that are like colliding to make them look right. So in this example, where I'm showing you how we use actions to do movement across the grid. So I'm using that actions API in here to move across and use that pathfinding to do this. So that little 2 that flew up, actions, pretty slick. All right. Before I get into how like the deep, dark guts of Excalibur works, does that make sense how you make a game in Excalibur, like a real basic level? You make actors and you add them to the scene, and there they are. And you can move them around with the Actions API, and you can add graphics to them. It's pretty low effort, I hope. If you're like, wow, that was a ton of effort, come talk to me, because we got to fix that. Okay, so for my game engine builders in the house, we're going to talk about how Excalibur works. Dun, dun, dun. How does it work under the hood? Oh my God, there's a sequence diagram. Okay, so there is a sequence diagram here, and you saw most of these things. In fact, you saw everything but ECS. That was on purpose. You guys didn't see any of the ECS, and you know what? You're happy because you didn't see it. Trust me. Anyway, so this is how the main loop works. There's a type called the clock that you usually don't interact with, but it's the driver of the periodic update. So we have 2 clocks. The first one is the one I like to call the standard clock, which is the one that everyone wants to use. And then I have a test clock, which only steps when I want it to, and it lies to the engine about how long the time has elapsed. This is super useful when you're debugging physics or platformer code, if you can be like, actually, game, that was 16 milliseconds. Step ahead for me. Let's debug the weird problem. So you can use the test clock to drive the main loop, or you can use the standard clock, which does, in the web world, there's something called request animation frame, which syncs up with your browser's refresh rate. So that's what the standard clock does. And that just drives the main loop. If your game has not loaded its main loader, it will then load. And before it gets into like, let's do the main scene, it waits for the ready. And once you're ready, then we're off to the races in the normal main loop. And it's what you think happens. There's an update and there's a draw. And it updates the current scene and it draws the current scene, which you might have guessed. But under the hood, it marshals down, it thunks down to the ECS hiding in Excalibur's, deep dark secrets to do the update systems and the draw systems, which we split into two. Cool, that's the main loop. Very standard. There's a train. Very fun. So the scene, kind of continuing that diagram to the right, goes and updates all the systems and calls the draw on all the systems. What that does is it says, okay, system, you need to do something. It doesn't know what it's going to do, but the system says, I have a query for all of the entities that match something I care about. And once that changes, or I delete an entity, I delete a component on an entity, it gets updated like magic. It's using an observable pattern. So the system knows when any change happens to an entity that it cares about. And then it just loops through and just wham, does whatever it needs to do. So if it's drawing, it'll just loop through all of the entities that have a graphics component, which actors are just, entities with a bunch of pre-baked things. That .actions, .graphics, turns out those are components. And that leads me to, wait a second, I know what ECSs are. That's not how components are supposed to be. They're not supposed to have behavior. Well, too bad. Purity is not the goal in Excalibur's ECS. So I find that in the purest sense, like an ECS that is just data only is great if you're working in like a native language where you can take advantage of that and get that cache coherency. It's a lot harder to do in JavaScript. It's also really hard to program with. So purity is not our goal. Our goal with ECS is also what I've told you before. You don't need to know that ECS exists. And our goal is not to purely, I should have put the word not in here, it is not to purely increase performance. It's really code organization. Like, it's really great for decoupling your code. And that's pretty much why we use it. It also does have some performance benefits in JavaScript, believe it or not. I was like, performance is not the goal, and then it wound up having performance benefits. I'm like, that's absolutely wild. That's cool. But it's really hard to program with, so, I'm not really selling you on ECS. Here's like some code of what if you wanted to be like, I want to go there. I want ECS. Do you have some? I would like some. Okay, so ECS in Excalibur, there's a world, which is the container for all of the ECS thingies, and the scene has one of those. So every scene has its own world. I know, confusing, right? There's a lot of metaphors for places, things, and actions. So this is taken directly from Excalibur source. I've collapsed the code to hide the sins, especially in the motion system. It's absolutely bonkers to make it fast in JavaScript. There are sins that are committed. I'll show you later. But if you wanted to do your own sin, system, it's Freudian slip there. If you want to do your own system, this is how you do it. So you go ahead and make a system. Systems are passed in the constructor here. Boop, 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 boop. Constructor. You are passed a world. It's the poor person's dependency injection. And with that world, you can say, hey, world, I'm really interested in things that have a transform, which is position, rotation, scale, and motion. I would like to do things with those things. And then you go ahead and you have an update with the last frames elapsed, and you do something. You don't have to do it with the query. You probably want to, but you could do all kinds of things in here. You don't have to query the ECS system. But in this case, I do. I go ahead and update all this. There's some old, you want to capture the old position for reasons here. But yeah, that's how you do like a very simple system. All right. What is an actor but a miserable pile of secrets? One of my favorite lines ever. So that's exactly what actors are in Excalibur, a miserable pile of secrets. It's actually ECS, haha. So it's actually an entity. So an entity is really just an empty thingy. The only difference between like this and other ECS things is entities also have an update lifecycle just built into them. and entities can have components. So if you're like, you know what, actor has too much stuff for me as a game dev, you can just go back to entity and you can build your own thing. You can be like, you know what, Excalibur has all this built-in stuff, I don't want it. I want to do my own thing. In fact, it's super useful if you want to do your own physics system or port in a new physics system. I have a sample of doing that. So if you're like, you know what, Matter.js is my jam. I like Matter.js a lot. Or I like my WASM port of Box2D. Be my guest. You can totally do that with a system. And in fact, I have a sample of doing that. So an actor just has well-named components on it. And these components do different things. You know, we've talked about transform in motion. Body is for that physics part. So body duplicates transform in motion. And in fact, it references the transform in motion components that you have. That's a choice. It has some coupling with those other components, but it works out okay. There's graphics, and the graphics component we didn't really dig into too much, but it's basically a container for holding any graphic in Excalibur. And then that's part of the magic of doing the automatic batch call, is you use the graphic of Excalibur. So you load in that image, .toSprite, bam, you got a graphic. You want to make a rectangle, new rectangle. That's a rectangle graphic. You want to do your own thing, and you're like, you know what, I like to draw my own stuff. You can do new canvas and just do 2D canvas API and draw your own thing. So you can just do lines and arcs and stuff. That's a graphic. So everything is a graphic at the end of the day. And then we can do colliders, which are what I talked about before, is like geometry. Cool. Let's talk about graphics. Apologies if this is really rough to look at. So this is Excalibur doing bunny mark of 12,000 things, which is pretty good. Pixie.js just announced that they can do 100,000 things, which I'm like, how did they do that? I think WebGPU is the answer, but I'm working up to that. But 12,000 is usually enough. Based on like what I'm looking at here, I don't think I'm going to have a game with 12,000 things. But I can easily hold 60 FPS on battery doing 12,000 draw calls. The way that we do this batching by default is we have our own context abstraction. So that's like the 2D Canvas API context, or like in your favorite like UI framework, you might have a graphics context where you can do drawing directly. We have our own graphics context in Excalibur where we encourage you to draw using that, and that just makes you batched by default. It's WebGL2 based. We have pixel art settings for those pixel art fans, because a lot of 2D games are pixel art. We have multi-sample anti-aliasing built in, and you know what? Most people don't know or care because we just have it turned on by default. And you know, if you're like, oh, I don't want that anti-aliasing, it looks too nice, I can turn it off. You can deeply configure all of these too. So there's like presets, but you can dig into the anti-aliasing settings and you can be like, okay, I want to turn on this, but I want to turn that off. You know, you can do things like that. All of the renderer, like deep down in the guts, all of the WebGL calls, or in the future WebGPU are renderer plugins. So even internally, drawing like an image or drawing a circle or drawing a line is a renderer plugin. And this is what builds up that, like if you're familiar with OpenGL or Vulkan or WebGPU, you got to build up these geometry buffers. You got to actually use WebGL textures or whatever graphics API you're using. The renderer plugin is what actually thunks to that API and produces that result on the screen. We have custom shaders that you can do. We have post-processing, and I've already talked to you about the batch draw calls. So how do we make that happen? So here's that Excalibur graphics context. That is exactly what it's called in Excalibur. You issue a draw call, but it does not happen. So when you call draw on the graphics context, it holds on to them. And it does kind of like a closure capture of the current state. So it goes, whoop, let me get the Z index, the opacity, any shaders that you want to apply, the position of this draw call, the renderer plugin that you're using. Again, that's usually hidden from you because we have nice APIs on the surface. So like I want to do draw graphic. And it's like, okay, that's an image renderer under the hood. Let me get that draw call. Let me put it in the list of draw calls. And then at the end of the frame, we go flush, and then we go ahead and quickly sort. We have an efficient way of doing the sorting, so it's not actually that expensive to sort it right at the end of the frame. So we sort, and we loop through every draw call that you had, and be like, okay, this draw call is this renderer. Okay, push, push, push onto that renderer, and if I need to switch renderers, okay, we need to flush the batch. So we go ahead, and usually you're using only one renderer, and that's the image renderer, because usually you're just drawing graphics. You're just drawing 2D images. So usually, that's just 100% batched. So you have one draw call, and we flush the batch. If you're doing something fancy with custom shaders, we gotta run a separate draw call for you because you have your own shader, because I can't control your shader anymore, so I can't do a batch. You could write your own batch call for that, but right now our custom shaders I can't batch even if they're the same. There is a way, I just haven't figured it out yet. But yeah, that's how it works. And then we run a post process on. We just have render targets where we flip flop 2 render targets. So we have, okay, render target 1, run the post process to render target 2. Oh, you got another post processor, flip flop, and then we blit to the final screen. So we take that final texture copy to the screen. Wham! And you can do that in OpenGL or Vulkan or whatever you're doing. So like this totally applies. So this doesn't have to be, in fact, like there's not, surprisingly low web in this talk. This is very applicable to anything that you're doing. Okay, and here's an example of us, or here's the example of the draw that does some wild TypeScript stuff. But given a renderer name, we can infer the arguments of the renderer plugin, like by magic. And then this is what gets that draw call and captures that scope. So we're capturing the current state of the Z, we're capturing the renderer priority, the renderer name, the transform, opacity, tint, material, and the arguments of the draw call that you had. And then look at that. We're just pushing it onto a list, which we will sort later and draw. Fun. And here's how the friendly API looks. So usually you call draw image, and you just pass in an image, and then this is us thunking to that renderer plugin, which is the image renderer I talked about. Cool. Custom shaders are fun. So here's an outline shader, which is super useful. You might have recognized this shader in some monsters where the witch was casting her spell, and she had a rainbow outline. This is not a shader talk, but I'm going to show it to you anyway. It's really cool. The gist is you sample your texture, and then you sample in a circle around it. And for like kind of a pixely outline, you do 4, because you go up, down, left, right. And then a radius of 2 pixels away. And then you can go ahead and sample and say, okay, so if I have a thing that isn't a thing, I'm going to go ahead and mix that with the desired color that I have. So like I sample and I say, oh, I didn't find anything. I'm going to go ahead and apply my outline. And then I go ahead and mix that final color. And then I get that lovely, lovely rainbow effect. Let's see if it'll happen live. Oh, this is our documentation, by the way. Yay! Rainbow render, yay. But yeah, go ahead and steal that. And the cool thing about like shader code is like it's pretty portable to everywhere else, unless you're using Unity and then you have to rewrite your shader code in something else. The other bummer now is WebGP uses a different shader language that isn't GLSL, so you need to rewrite your shader in WGSL, which is a real bummer. But yeah, fun stuff. There's also a fire shader, which I can show you as well. If you're at all curious, the technique here is we just have a noise texture that we're scrolling up, and we're just, get rid of that. It's a cool effect. And we're just mixing based on the Y right here, how much RGB. So if I get rid of that and I hit save and I run, we can take a look at that. And then you can see the magic is undone. It is now a scrolling noise. But yeah, it's a really neat effect, and it's like really, terrifyingly low effort shader to write. But that's fun. And you can see what that looks like here in Excalibur. We have an image source here where you can specify your blend modes. So like, all of this stuff happens by default. We pick up blend mode for you based on like, oh, did I want pixel art? You probably want a particular blend mode. So we can just pick the right default for you. So you don't need to know the defaults that you need to do. But if you do know, you can go ahead and set them. And then I also want this to wrap because I'm scrolling the UV. And if I scroll past one, then if I don't wrap, then I just get like a smear. So the way this works is you go ahead and create a material, and you can name it. The debug plugin, just if you add a name property to things in Excalibur, the debug plugin can show you a nice name. Otherwise, it can't. So that's the reason to name things, is like in your debugger, you can see nice names. So standard actor, you'll notice that I gave it a color, but we're deciding to do something else here with this material. So this, this shader takes over, shader take the wheel, like that. But yeah, that's how you do it. And this is all in one file, and I just have that loader in line with the start. But that's what we did. Pretty fun. And that's how you do custom shaders. Whoa. It's pretty slick. I'm gonna go to the next frame here. Okay, you can do post-processing. It's very similar to what materials look like, except it applies to the entire screen, and it applies after the whole like all of the draw calls have finished. So you can do this cool like CRT effect, or any cool effect that you can find on ShaderToy, which is where this is from. All right, we're gonna move to sound. Sound is pretty boring, except for the web, frustratingly, only supports, like, depending on your platform, your browser, operating system, you may or may not support every type of audio file. So you need to supply, like, fallbacks. So you say, okay, MP3 usually works, but if I don't have that, fall back to WAV. If I don't have that, fall back to OGG. And you can decide, because it's hard to know a priori what browser you're gonna be using, just give a list and it'll go down the list and just do, like, Excalibur will do a quick test to see if it can play it and be like, nope, 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 yep, okay, we're good. And that's how it works, and you can play at a volume. Yeah, sound isn't super sophisticated. What is, oh, yes, question. Great question. Scott asked if. Yes, great question. Scott asked, is there any like lightweight like audio decoders that you can include in JavaScript as a fallback? Totally. There's a lot of them. I didn't do that in Excalibur, but that's totally like that's kind of how the JSFXR works. Is it generates a waveform on the fly using the the parameters that you pass it. And there's also like a lot of mod tracker stuff that very similar, like MIDI or mod or whatever, floats your boat. But Ogg Vorbis, you could totally do the same thing. That actually would probably be a really cool plugin to write. So I've been pushing all of our like third-party dependencies into plugins. So the core of Excalibur is dependency free. But I would love to have an Ogg Vorbis decoder in Excalibur. We have a GIF image resource in Excalibur that'll import it and like read the the GIF format, excuse me, and produce an animation too. So like that's a cool idea. I like that. FLAC would be rough. Okay, we're gonna sit here and download a gigabyte of music. Yeah, that's sound. Sound is fun. Sound adds a lot. There's some stuff we're gonna be adding that isn't in there right now, is like global audio managers. I wind up writing this every game, and I've written it like 15 times, so I'm just gonna port what I write every game into Excalibur. But roughly speaking, you wanna do a global mix of, depending on your audio, one might be loud, one might be quiet, and you need to adjust volumes. You wanna do a different mix, or you wanna globally turn all of the volume up or down instead of like adjusting every bit of audio manually, which you have to do right now, which is working on it. Yeah, global audio settings is coming. That's not in Excalibur yet. Collisions! I will nerd out about collision detection all day long, but Excalibur has two broad phase techniques. So broad phase is just like, for the people not in the physics parlance, a broad phase is like quick and dirty check to see if anything could possibly collide. Your naive check is like for every object, check every other object in the scene. That's your naive broad phase, where you're like, okay, we're checking everything against everything, which is n squared. So generally, that's kind of rough. So you want to come up with some spatial partitioning strategies to see like, okay, these objects are close by, they might collide. So that's what the broad phase does. Is it says, okay, let me narrow down the search space to like, okay, these might collide. There's also like popular algorithms like sweep and prune, where you sweep across all of your x coordinates and all of your y coordinates. That's also popular. I've had middling results with that one, especially when things are densely packed. Anyway, we have two spatial broad phase techniques. One of them is a dynamic bounding box tree, which works great, except if you're on Firefox and you have a super deep tree depth. Firefox, for some reason, really hates recursion. It really does not like it. So we switched it to a simpler one that actually works a lot better. It's just a spatial hash, like a hash grid. So I just hash the coordinate to a bucket size, and then it's sparse. So you can have infinite sized world, as infinite as IEEE floating point numbers can get you. But that's how we do our broad phase. Is like, oh, are you in the same neighborhood of cells? Okay, you might collide. We use separating axis theorem for our narrow phase. Narrow phase is just like the expensive phase, where we're like, oh, does it actually intersect? Like, do these two shapes overlap? And separating axis theorem is kind of intuitive if you think about it. It's like, if I had two shapes and I shine a flashlight around them, if light comes through a gap in the shapes, there's no collision. So it's basically you're circling the shape with a flashlight is the metaphor. And then this GIF is really appropriate, because this is how the collision solver works. It really just shakes a bunch of puzzle pieces in a box really hard until it kind of shakes itself out. And that's kind of how like impulse-based physics works. Is you give it a small impulse, and if you've ever done steering, like where you're like, okay, this is where I am, this is where I'd like to be. I'm gonna go like a little bit in that direction, and then rerun. And that's how the iterative constraint solver works. It just loops through it multiple times. It's like the puzzle pieces have magnets magical magnets to the right spot in the final solve puzzle, and you just shake the box really hard until the puzzle is solved. That's how it works. Isn't that wild? It totally works. It's relatively stable, and it's actually not that, it converges pretty damn fast. It's like in practice, don't need too many iterations to do this, which it's absolutely bonkers that this works. But it's great. It's also what Box2D does. So if you're like, oh, that's a silly idea, Box2D does it. And here's an example. If you want to read a blog post on this and play with it, I have this little example, just minus all the Excalibur. It's just an example of doing this kind of iterative constraint satisfaction problem. EricOnerheim.com. Cool. And then there's the arcade resolution, which you've seen before, is probably what you want for most games, especially for this game here where we have like Super Mario World physics. Arcade Collider works pretty well. I'm not going to make you watch this again. The arcade solver works like the other realistic solver does. So, once you've figured out that something is going to collide, like you've got a collision contact where you have two objects and you have some information about the nature of their connection, what we do is we say, okay, we're going to iterate through all of the contacts and figure out, depending on your solver, you say, okay, I'm going to make sure that they're not overlapping, so that's solve position, and then I want to do something with the velocity of these objects when they're colliding. In an arcade solver, we just zero out the velocity in the direction of the collision, which is usually what you want. And you can mess with things if you want. There's some hooks to the pre-collision, post-collision, collision start, and collision end, so you can just decide you know what, Excalibur, get out of my way. I'm going to do something else. So you can totally do that. But this is how the arcade solver works. This is nuts. But if I can summarize this wall of code, what's happening is saying, okay, there's a couple of degenerate situations where we're like, okay, we don't want to solve this contact. Like for example, like you're barely intersecting. We're like, okay, we're gonna skip those. Or you overlap by like a marginal amount. We're gonna skip those. Otherwise, what we're gonna do is like, oh, there's overlap. We're gonna split the difference and shift you that half and half. That's what's happening right here. That's it. Pretty simple for solving the position. And then solving the velocity is what I talked about before, is in the direction of the collision, we're gonna go ahead and negate that velocity. So that's what's happening there. And then I just collapsed the other side of that equation for brevity. Does that make sense? I mean, that's arcade collision. It's pretty simple-ish. Simple-ish. Simple adjacent. And then if you're super excited about constraint-based solvers and you're like, I want that in my life, you know, that looks familiar. You can see a derivation of the whole approach. And it's based on a GDC talk by Aaron Cotto in 2014, who is the author of Box2D. I watched this talk, no joke, like 30 times on repeat to write this blog post, because that talk is so dense. But if you're ever like, how does Box2D work? And you want like, I'd like to think more readable and like an explainer, check this out. I don't know, maybe it's not more readable. You tell me, you send me an email, I'll be okay. I'll graciously accept the feedback. We have particles, yay! Coming soon, GPU particles is what I'm showing there, is I can crush 10,000 particles at 120 frames per second, no sweat. There's some downsides to doing GPU-based particles, but you can sure do a lot of them. And so like, as you can see, like I can just like, look at all the little duders flying around, and then you can do like cool things like, cool techniques like a collision mask, which is just a PNG that is like black and white, and then you sample the texture where your particle is gonna go, and if it's like black, then you'd be like, no, you don't go there. And that's how you do collisions with particles in a really efficient way on the GPU. It's completely wild. So currently it's CPU particles, but I can crush, like I think, we can crush quite a bit still. I have, you know what, I'm gonna show you I have a particle tester here. So I have you know, these are CPU particles right now, but you can do cool stuff like this. We have a little like, oh, you know, there's a lot of little settings on a particle, so you wanna like play with the slider and whatever. So you're like, okay, I got normal fire, but you know what I really want? I want ghost fire. Ghost fire is white, I think. And then outside it's got blue. Ghost fire. Very cool. Yeah, so we have that. That's excaliburjs.com/particle tester, and that'll just plop out all of the code that you need to run the latest version of Excalibur, latest released. So it's pretty fun. And you can do sprites too. I'm not showing you sprite. Well, we can do that right now. Let's do it. Why not? Who cares? We're all friends here. We can go ahead and add some sprites to that. I'm going to add a sword, and we're going to just emit swords as particles, which sounds really dangerous, but I think it'll be fun. So I'm going to go ahead and build this with my ancient build script. This is really, we're seeing the sausage be made, because no one should ever run this script but me. Okay, so now this is that emitter, and let's go see some swords. Oh, yeah. Oh, that looks dangerous. Delicious. Keep your hand out of there. Okay, cool. All right, that's particles. Let's see how we're doing. We're doing great. We were talking about, we have tile map support and isometric map support. And this is the part of the talk where I bounce in and out of slides and maps. So, you know, we can zoom in here and see this, this tiled map, and maybe we can play around with the coin here, and we'll move the coin around. The coin's gonna live here now. I'm gonna save that, and then we're gonna go over here and go take a look at that. I did that on this one. And enhance. Now the coin's over there. And I can move my player around. I collide with the wall. You can't really see, but I'm hitting the arrow key really hard into the wall there, and he's not going anywhere. But you see, you can build up games really fast. This is actually a great way of iterating, because like if I change this right now and hit save, like Vite will just reload the game, and then the coin is now over there. Pretty slick. This is a big part of how we crank out games for LD so fast, is like this just allows us to iterate super quickly. And then, there's a, isometric map, which is very exciting. I know if you're like me, isometric is like your bread and butter. You played Mario RPG and you were enchanted, both by the dialogue and the wonderful art and the pre-rendered 3D assets. Fantastic. Super fun. Yeah, okay, so that's tile maps and isometric maps. I recommend tiled if you're gonna do isometric. I do not recommend a tiled for any other use case. Use LDGK, it's like way better, at least for me. No shade, tiled is a workhorse, and everything will work with tiled. So, use what makes you happy. Cool, isometric. Coroutines, and so this might look familiar with the classic diamond move and then a fade out. So let's look at what that looks like in a coroutine. So Excalibur supports coroutines by default, and you can just do ex.coroutine or import coroutine, and you might see this wild looking thing right here, this asterisk on the end of a function. You'd be like, what the heck is that? That is not my function. My function has a weird asterisk on it. So what those are in JavaScript is it's like, oh, that's a generator. So that's just like in C# if you have like a, I think if they're called generators in C# or they're called iterables. It's basically that. IEnumerable, thank you. I work in C# daily and I totally forgot what they were called. But what happens here, which is pretty cool, is I can do crazy stuff like this and just do a while loop in something and be like, YOLO. While loops are fine in coroutines. Normally, I would be like, yo, you just put a while loop in your code. Don't do that. But what's really cool here is like yield pauses the execution and yields back up to the main thread. So it says, okay, I'm gonna do some work. In here I do some pre-work. I'm like, okay, I'm gonna do this fade thing. I'm gonna calculate a bunch of values I'm gonna need to do this fade animation. And then while duration's not 0, I'm gonna go ahead and do my thing. I'm gonna go ahead and yield. And outside the left side of the yield, this is pretty wild, out the left of the yield, it's kind of like a weird return statement that is bidirectional. And in fact, that's coroutines, right? You're sharing between you and someone else. So that's what coroutines are all about. So this yield returns out the elapsed time, and I can use that to do whatever I feel like. I can pepper this with more yields. You can think of a yield in an Excalibur coroutine as 1 frame. So every yield I have, that's a frame. Another cool thing that I didn't have in this example is you can also yield on the right side. You can be like, yield 200. That means come back in 200 milliseconds, please. Pretty cool, right? So you can do wild stuff like that. And you can also yield promises, and it'll do the same thing. Question from Scott. Are JavaScript generators stackful? I have no idea. Oh, great question. So can I call another generator from inside another generator? I totally can, but you have to do a special operator to do it. It's called yield star. So if I have another generator inside my generator, I have to do yield star to call another generator, which is kind of funky that you have to know that what you're calling is a generator. Kind of sucks. In the latest version of Excalibur, you can yield other coroutines, and Excalibur just figures it out. So you don't need to know that you're necessarily calling another generator. You can just do yield coroutine and it'll work in Excalibur, but doesn't work on JavaScript by default. I don't know why they decided to do that, where you want to yield deeply into another generator as yield star. Anyway, cool. So that's fade. So I want to fade. And then, we saw a move by earlier, and this is that implemented in coroutines. Same kind of deal. I do like my pre-work. I'm going to do while my duration's not done. I'm going to go ahead and move my thing over time. And then at the end, I want to just true things up and just say, okay, this is where I wanted to go, because you might be off by a fraction at the end of your coroutine, so you want to just true things up there. So that's what this code would look like in my actor. I can go ahead and throw around this async keyword. This is what you think it is in C#. It's just async await. And I can go ahead and await coroutines, and that'll move them serially. You can also start coroutines in parallel. That's totally fine too. So I'll move in that diamond pattern, and then and I'll fade out, which is what we saw. Fun stuff. And then usually what you're doing with coroutines is you got something really complicated, like a really complicated animation, and you'll cook all of that into your coroutine at once. So you might be doing like, okay, I gotta switch my animation, like my graphic that I'm using. I've got to like update my velocity. I've got to do a whole bunch of stuff at once. I'm not just changing one facet like I am here, like I'm changing opacity, but I might be changing multiple facets at the same time. That's where coroutines really shine. Can recommend coroutines. They're my hammer for a nail, my Maslow's hammer. I use them for everything. Okay, whew. We've been talking for a long time. JavaScript optimizations. I learned a lot about JavaScript optimizations. I have a half-written blog post about all of the things I've done to optimize JavaScript. The most important thing about optimization is to measure and then optimize. Not optimize, then measure. It's very important to start with the measuring, because a lot of times, and I get like 50-50, I'm like, oh, this will make it faster. Turns out it doesn't, for a reason I didn't expect. So make sure you measure. Optimize, then repeat. So that's step one of optimization. Measure first. The trick, the dirty secret that no one will tell you is that optimization boils down to doing less work. How do I do less? And that's what you got to do. It's like you got to come up with clever ways to not do as much work. That's really what happens. It's like, and there's a spider web of strategies to do less work, and a lot of them are efficient data structures, spatial partitioning being one of them, but there's a lot of other techniques that you might be like, okay, how do I early out of this? Like, is there like a 99% happy path here? How do I make that the easy path? Like, how do I avoid doing unnecessary calculation? That kind of stuff. In JavaScript, there's a sad, sad story that C-style loops are the fastest, because there's a lot of really cool loop constructs in JavaScript. You can go .for-each, .map. It's all functional programming. It's super fun. They are really slow, because you're paying for a function invocation. You can also do, you can loop over generators. You can loop over iterables. Those are also slow, because you're paying for function invocation of the generator under the hood. It's really sad. I have gained a ridiculous amount of frame time back by switching to C-style loops. And that's what I mean by that is like for I equals 0, I less than length, I plus plus. The loops that you know and love. But if you're in like another language, you might be like, oh, these other languages have really cool loop constructs. A lot of times those loop constructs cost you, unfortunately. But it might not matter, so this is why we measure, because if you're iterating over like 2 things and you're not doing it in a hot loop, use whatever loop construct makes you happy, because that's not going to affect your frame time that much. You're not going to be able to measure the cost. But if you're in a hot loop, maybe it does matter, so measure. Don't just go and do C-style loops just because they're faster. Do them because you need to. This one is sad for me because I love recursion. Because I love recursion. But some JavaScript engines really struggle with this, and I'm not sure why. And I said Firefox before, but Firefox really does not like recursion. So if you can, avoid recursion. And I'm wondering if it's some kind of tail call thing or stack frame replacement thing where, like, if you're tail call optimized, you can just reuse the same frame, right? Versus like pushing a new frame and doing all of that work to do a new stack function. But I don't know, function stack, excuse me. This is a hot tip. I didn't realize this until like the last month, but it turns out the new keyword costs you. If you can avoid using new thing, especially in a hot loop, this doesn't matter what language you're using. Doing heap allocations sucks. Like, it will eat into your performance in a hot loop. So like for me, I spit out a lot of like math types, like a vector, and I'm like, for a lot of stuff, a lot of the sins to make it fast is me like mutating vectors, because mutation is way faster than doing a new vector to save on the type. But it's way easier to blow your foot off when you're mutating vectors, trust me. The new keyword is dangerous in a hot loop. So a lot of times you pre-allocate a buffer of scratch objects that you want to use, or you use an object pool. Object pools! Object pools are great. I get a lot of perf out of object pools. I use them a lot. And then caching. Caching is also super hard though, because it's one of those classic computer science problems that's super hard. Off by one error is caching and object pooling, you know. Caching. Okay, whew. Thank you for listening to me talk for so long. So let's talk about the future. Where are we going? Accessibility. This is like my numero uno on my list of things before version 1 of Excalibur drops this year. We're going to be improving colorblindness support. We have the 3 most popular forms of colorblindness. Popular? Common. Popular is probably not the right word. Common forms of colorblindness, but there's a lot of other forms of colorblindness that we want to support. We want to support as many as we can, just have them built in. And they're super cheap to do because it's just, under the hood, it's just a post process. Because what we're doing for, like, simulating colorblindness is we can nudge the pixels into a range where me as like a person that's normally or fully sighted, I can, you know, perceive the problem. So like, for example, if I wanted to see like that red-green colorblindness and look at my game, I can be like, oh, I picked exactly the wrong colors for this game because I cannot discern one thing from another. And again, remember, 1 in 10, these people will be playing your games. And there's probably someone who's colorblind in this room. You know, it's really important. My boss is colorblind, okay? Like I showed him a chart with red and green lines, and he was like, I got nothing. I got nothing for you. He's like, what is this representing? Because I can't tell. Because the legend had red and green next to them, and the lines were red and green. So, you know, definitely check that. But so we really want to support every type of colorblindness that we can. We do also have a thing where it'll nudge the colors to try and correct. It's not the best. It's kind of a, oops, we didn't think about it, and we have a final game, and we can't redo our art. You really should start at the beginning and think about colorblindness, again, because 1 in 10 are colorblind. We also want to add high contrast. So that's just a hugely helpful tool when you're playing a game, is if you are having trouble seeing, for whatever reason, high contrast can really help. HTML-based UI, we've been working on this a lot, but if you use HTML-based UI, assistive technologies already can use the browser. And if you're doing normal HTML, those technologies can read it. So if you do canvas like text, like you render like a bitmap of text, you got nothing. So you need to do other things to make sure that folks that are using screen readers can read your text. We're looking at adding like ARIA announcer support, so you can direct assistive technologies to read something to a user. It's usually like something that happens dynamically on the screen, because what will happen is like you'll load up a web page, assistive technology will read the whole page, but something might change on the page. Like maybe you have a stock ticker, and they would never know unless they tabbed up to that stock ticker again to know that it changed. So the announcer is like, oh, by the way, something changed that you might want to know about. So that's what ARIA announcers are, and that's what we would use in there. This is also a really cool one that we want to do, is we want to have like control input mapping out of the box. So we give you a plugin that you can just throw in your game, and you just get like a control pad API, and you can be like, you know what? I don't like how this is laid out for my needs. Like, you know, either like, I don't like WASD, I want to use arrows, or I want to use IJK. You know, I don't like WASD, I like IJK. You know, you could do that. Or if you have assistive setup where you have like different paddles, different like buttons and stuff for whatever your needs are, we can just make games work for you. So we just want to have that out of the box. So that's one of our goals. And if there's something on this list that I didn't include that I should, you should tell me. We're going to do headless. Oh, damn. Yes, Discord. Share my screen. You did not see this. Don't look behind the curtain. Okay, so right now we're coupled to the browser, and we'd like not to be, for the reason that you can't run Excalibur code easily on a server, even if you want to, even if you're using Node, because we have hard dependencies on the browser. There have been some really cool hacks that people have done to like shim out browser APIs and make it work. But we'd also like to support like Node, Bun, QuickJS. Also, one benefit for me is my tests will run faster because right now I have to spin up a browser and run my tests, which less fun. We're going to look at WebGPU. So WebGPU is right now only on by default in Chrome. There is a promise of greater performance because everything is actually using Vulkan or Metal under the hood, and it's not using OpenGL. So WebGL is doing like 2 translations. So you're translating from WebGL into like this OpenGL construct, and then we're translating into Metal or Vulkan or DirectX or whatever you're using natively. So what has been said is there's fewer layers of translation in WebGPU, therefore it'll be faster. This promise is yet to be seen. We'll see if that is true. Measuring will be the real prover. There's also a thing that you might be interested in. It's called 3JS shading language. One of the huge bummers of WebGL is that it's got a different shading language. But this will compile to either WebGL, or what is it, GLSL or WGSL, depending on what mode you're in. So this is pretty cool. So you can just write shader code in JavaScript, and what'll fall out will be either GLSL or WGSL. So this is something that I'm looking at because writing 2 versions of your shader would really suck. I would not like to do that. But a lot of people are doing it right now. Continuous collision is something that we have middling support for. It's doing like a very basic raycast, and it's like so-so. So improved continuous collision. I'm doing a lot of research for this. I'm writing a blog post for this. Turns out it's hard. There's a lot of hard problems with continuous collision. It's also really expensive. So that's, here's Aaron Cotto's demonstration of like the bullet paper problem. Oh, you can't see that. Weird. And back forward. I might just kill my Discord and we'll try again. I think Discord's dead. He's dead, Jim. Oh, can I not kill my Discord? Oh, quit Discord. There we go. But we have the classic bullet paper problem in physics. Cool. I remembered that I should be muted. So if you're, like, for example, if your floor is too thin and your update is too large, you might bounce through the floor. And you probably have experienced this before where you're teleporting through a wall or you're going through a floor, and it's really frustrating, and it can be game-breaking. So continuous collision is super nice. I'm building an editor. Holy moly. So a lot of people are like, this code thing is great, but I'd really like to click and drag, including me. I would really like to lay out my levels with the mouse because guessing with numbers is really hard. I really don't like that. Oh no. We lost the screen again. I blame the presentation gods. Well, okay, cool. All right. So there's a few other things, like people are like, okay, this is cool and all. You said JavaScript can run everywhere, but can it run on the console? The answer is no, right now. but I have an experiment that's working. So the answer is yes, you can with enough C code, write JavaScript and have it run on a console. So there is C code involved. There is an Excalibur.js runtime on my laptop that can run, but it's a limited subset of the browser, right? I can't implement every browser API, otherwise I'd be writing a browser. So there's a couple things that we can do. Is like there's wgpu.rs, which is the Rust implementation of WebGPU, and then there's the Google implementation, which is Dawn. So I'm looking at things like that. Right now I'm using an OpenGL library to do it, and it's okay. Publishing, we're going to be going to Steam with some monsters soon, and then we got a mobile game in the works. So hopefully that'll come soon. Probably not in 2024 though. Cool. Yeah. Shameless plugs. Thank you all for being here. I've got a newsletter, news.excaliburjs.com. I'm making courses eventually, excaliburjs.tv, if you would like to sign up for either of those. I promise not to email you more than, maximum once a month. And this month you're not going to get an email. So, huzzah, sign up. You won't get emails this month. We have blogs where I have not written a blog post in a long time, but other people are writing really crazy cool stuff, like wave function collapse, pathfinding. There's really good stuff. I have a YouTube channel. We're going to be at 2DCon handing out stickers and showing off our games, and maybe an editor, knock on wood. But we'll be showing off games at 2DCon and giving code demos and stuff. Yeah, groovy. I think I'm at time. I'm not going to bore you with any more. Any questions? Can you believe that I filled 2 hours of Excalibur content? Wow.
Hi.
Hi.
First, kudos to you. My first game engine was written in JavaScript, and that was what convinced me that I should not be writing game engines.
I've had that thought over the years many times.
Anyway, so notably, Excalibur is focused on 2D, and I suspect that's probably due to the Canvas API integration. Have you ever thought of changing that under the hood to start supporting 3D? And if so, when?
This is a great question. The plan is to never support 3D. So, a few reasons. 3D is hard. It comes with a lot more problems to solve that are really hard to solve. And there's a lot of other 3D engines that do a really good job right now, like 3GS, Babylon, in the space. If I do 3D, it's going to be a different engine, probably similar to Excalibur, but I'd probably be like doing low poly stuff is like what I'd focus on, because like the PS1 era really excites me, of that low poly like 3D graphics. But that's probably what I'd do. But yeah, Excalibur will only ever be 2D. Any other questions?
We've got one from the chat. Does Excalibur have audio spatialization options, either 2D left and right pan or 3D?
This is a fantastic question. I have a PR out for it. It's currently bugged, but the plan is, yes, to have audio spatialization. So you can do left, right ear, or what is it, 3D audio, I think it's called, in some circles. But yeah.
All right, so I'm really intrigued by your proposal to use HTML as your UI rendering, because as someone that attempted to marry Phaser and React and did not have that go particularly well, that feels like it's a challenge. So how do you plan to accomplish it?
Yeah, this is a great question. So like game loops traditionally run at like 60 FPS or more, and if you try to update the DOM at that speed, you'll be real sad, especially React, because React will just churn really hard. Doing its change detection and doing its VDOM diff. So you can't do that. So generally what we do is either A, don't update the DOM in the main loop. So you do it in like as a byproduct of events or other side effects. The other option is we've been experimenting with is like with signals. which kind of inverts the situation where you have a signal that exists outside of your main loop where you can poke it and give it new state. And then quite separately, your UI is existing and listening to that signal. So then you're not churning at 60 frames a second. If you're 60 frames a second updating a signal with the same value, nothing needs to happen. So like Boku savings on rendering React or rendering solid.js, which is what we've been experimenting with. I've been using lit, but doing a similar idea where you throw up something to an observable or some state, you flag it as dirty, and then you re-render your UI when something's dirty. So, yeah. But I can recommend using HTML as UI because guess what? The browser's really good at building UIs. Building UIs through rebuilding it through the Canvas API or anything else is just going to be a really crappy version of a button versus HTML has buttons that we can just use. Can recommend. Any other question? You're like my favorite person.
You can probably tell I've done some JS in my time. So, continuing down this line of the HTML as the UI, how are you syncing the positions within the game with the positions of the UI?
Oh, this is a fantastic. You're like, are you a plant? Yeah. So Excalibur has a screen. So off of the engine, there's a screen abstraction. So you can ask it for, hey, I have this point in the game world. Tell me where it is on the screen. So generally, what we do is we say, okay, well, I have this point where I want UI to be positioned, and then I absolutely position my HTML over that. Is generally what we've been doing, and it works okay. And then if you want it to scale with the same pixel density, the trick we've been using is we throw up a pixel conversion CSS variable on the root document. We just convert hey, what is 1 pixel in world space to screen space, and then you can just use CSS variables to multiply the width and height and just dynamically size it. And you would not know that it was HTML. We showed off some monsters, and I told people that it was JavaScript, and they're like, no way. That is not JavaScript. You were lying to me. But yeah, if you do it, you can make it look like a native game.
I've got a more of a softball, conceptual question. What was the initial inciting circumstances that prompted you to want to make this game engine in the first place? And as you've been developing it throughout this whole time period, how has your goals for it either changed or come to fruition, I guess?
This is an awesome question. You are also a plant. So this started in 2013 when I got voluntold to give a presentation about TypeScript by my boss. And I was like, okay, well, I like TypeScript. And at this time, TypeScript was 0.8. It was still on Codeplex, it wasn't on GitHub. So it was Excalibur's been around since TypeScript started. So I was like, okay, well, what can I do that I would have fun with? And I was like, oh, I'll make a game. And that's how Excalibur started. And the original name of Excalibur was Game TS, which, whoo, that's a rough name. And then and then the other reason I kind of kept going with it was a lot of the JavaScript game engines and stuff at the time, and a lot of game engines at the time were paid. You needed to pay money, which is fine. People need to eat. But I was like, you know what? I really want to democratize games on the web. And the web feels like this should be open source. So that was part of the impetus at the time. A lot of the game engines, I'm not going to name any of them, were paid at the time. And I was like, well, I can do this, and we'll make it free. And then over time, I've been really wanting to democratize access to games. So right now, I have this chart that I have posted on my wall, which is the users we want to serve. So right now, there's 4 user camps. There's the Excalibur experts, there are 6 in the world, which we serve those really well. But that's not really a great market to advertise to and to serve. And then there's the normal web developer, and I think we serve them pretty well. So folks that know and familiar with JavaScript, they are able to pick this up pretty well. Then there's the normal programmers. Web developer is kind of a special breed. I put myself in that. We have the most wild stuff going on in our tooling. So there's normal programmers that I would really like to serve better. So people that are normal programmers that have normal programming jobs that also would like to make games. So I think we serve them okay, but not great. And then there's the code newbie, which is my target. I really, really, really want the code newbie to be like super productive. So which is informing a lot of the API decisions that we're making and a lot of this like drive towards an editor, which will be free, by the way. The editor is free and it will be open source. But it currently doesn't work, so it's not open source right now. But I really want the code newbie. So I really want to shift left towards that code newbie. And that's our strategy. And you know, there is a plan to make money, but it's not that, you know, it's not on the engine. It's like we're looking at becoming a publisher of games, and we're looking at like, okay, how do we get to consoles? Like that's that end of the value chain. We just want you to be able to make games for free and just do whatever you want to do with them. And the web is a great place to do that. And that's kind of how things have evolved. I made a business for it, and so we'll see how it goes. It currently makes approximately $0. So we'll get that money train rolling. So that's currently how much Excalibur makes, is $0. The joke was, is it approximately 0 because of JavaScript rounding? And I thought that was pretty great.
Well, as a programming newbie, I'll be looking forward to hearing more updates that will hopefully get posted in the IGDA-TC Discord about any shifts or updates in that regard.
Awesome.
Because that sounds really cool.
Cool.
Any other questions, gang? Give it a good old 5, 4, 3, 2, 1. Not seeing any hands, so we'll call it good. Thank you for the wonderfully comprehensive
Thank you.
presentation.
Thank you all. I've got stickers. You should take some.
That's wonderful. Okay, so we're gonna chit-chat for a little bit, mingle. Before we scatter to the winds, people who are interested in food, I'm gonna ask you to raise your hand a couple times. We've got options. Currently, I think we're leaning between Pizza Luce or Applebee's. If anybody has any other locations to just really skew the vote, now's your time to shout them out. Otherwise, we're gonna do a show of hands of the people who are interested in food, which they would rather go to. The pros and cons of either are, Pizza Luce is about a 15-minute drive away. It's about 4 miles, mostly north of here. The main drawback is the distance. And then Applebee's is much closer. It's about a mile away, but the on-ramp to get back onto 494 is currently under construction. So as far as my understanding is, easy to get there, but might be a pain to get back to wherever you're going if you need 494. But as a pro for Applebee's, half-price apps. So, show of hands for Pizza Luce, people who are going to get food after this. I'm gonna keep. Yes, we can also do a vote for both. Okay, keep those hands up. 1, 2, 3, 4, 5, 6.